All good. All right. Well, thanks very much for coming to this talk, and thank you very much to Chris and Louise for organising. I'm sure it's not easy to find 12 speakers just before Christmas, so credit to them. Today I'm going to talk a bit about Svelte and WebGL. WebGL is something that's interested me for a while, and I haven't really had the opportunity to dive in and use it, but I've always thought it was cool, the effects you could create with it and some of the experiences you see on the web. So recently a library for Svelte was released that kind of bridges the gap between Svelte and WebGL using Three.js. And I had the opportunity to play around with it and make some animations with WebGL. But about me, my name is Martin. I'm the co-founder of Bodybase, an open source low-code platform here in Belfast. So what is WebGL? WebGL allows developers to create 2D and 3D rendering on an HTML canvas using JavaScript. And the WebGL library itself is a JavaScript API for rendering high performance interactive 3D graphics within any compatible web browser. Pretty much any modern web browser has support for it now. And it does it by introducing an API that conforms to the WebGL standard and allows you to kind of use the WebGL API, but also mix it with web elements and use things in the DOM. So it sort of bridges that gap pretty nicely and allows you to take advantage of hardware graphics. So it actually uses the GPU and you can create effects like this. Obviously a pretty advanced example, but you can see the sort of things that you can build with WebGL. And WebGL programs essentially consist of control code written in JavaScript and shader code, which is executed on the GPU. So who uses GPL? The big one that most people know is probably Unity, the game engine. It makes pretty heavy use of WebGL. Google Maps used it for Google Earth and for the Google Maps terrain view. Rolex uses it on their online store, so you can see 3D models of the watches and things like that. It's also very popular in the medical industry for things like models of organs and being able to model pictures of the body and skeletons and things like that. Microsoft use it as well on their online store for things like the Xbox store, where you can build custom Xbox controllers and model them and move them around in 3D models. So before we dive into any of the WebGL stuff, it's probably a good idea just to tell everyone what is Svelte. I'm sure most people here have some familiarity with Svelte, or at least have heard of it. And essentially it's a compiler-based UI framework. And that means rather than doing a lot of the work at the virtual DOM level, like React or Vue, it does a lot of that work at compile time. So you write your Svelte code, it then compiles it into pure vanilla JavaScript. So there's no runtime or anything like that. It doesn't make use of a virtual DOM, and it kind of surgically updates the DOM when updates need to be made. So it's very performant, it's very lightweight. It also relies heavily on reactivity. So it has a nice syntax for that. You can just use like a $sign to make a variable reactive. And when you update it, other things can react to it. It's very simple to use and it's easy to reason about. There's a big focus on developer experience to make it easier for developers to use it. There's really nice tooling around it. It's super simple to write. And it's just a great experience all around for developers. And the focus really is on simplicity. I like to say that Svelte for me is kind of, if they were to completely rebuild like vanilla HTML, CSS, and JS, that's kind of what Svelte would be. It's like all those things on steroids. So Three.js, the library I'm going to use inside Svelte makes use of Three.js. And essentially, Three.js is a much cleaner wrapper around WebGL. It's kind of like the React of WebGL almost. And because WebGL is so low level, like it can literally only draw points, lines, and triangles, it's hard to build anything sophisticated with that unless you really know what you're doing and write tons and tons of code. So Three.js provides things like scenes, lights, shadows, materials, textures, and makes it much easier to build these 3D animations. So the combination between them, Svelte and Three.js, as I mentioned, I'll be using the Svelte Cubed library, and this is a fairly new library developed by Rich Harris, and it lets you build WebGL based apps with Three in a much more kind of declarative, performant and clean way. And in the same way that Svelte kind of declaratively abstracts over all the messiness of imperatively building and updating the DOM, Svelte Cubed does the same for Three.js. And it was born out of the need of the New York Times and Rich Harris to build 3D animations for the Olympics. So they were building all animations of swimmers and different athletes and things like that. This is the structure of a Three.js app, essentially. So you have at the top here this renderer, and that's just the renderer for the entire scene. And the scene contains your camera, which is the camera that actually focuses on the scene. And you can set the camera at a certain angle, you can set it at different coordinates. And then inside your scene, you have what are known as meshes. And meshes are really just a combination of a geometry and a material. So for example, a mesh might be a blue sphere or a red triangle or something like that. And you just make up your whole scene with these mesh objects. And that's how you create Three.js applications. So as with anything, a hello world example probably shows this best. In here using the Svelte Cubed library, this is a demo of using Svelte Cubed to render a simple Three.js mesh inside of Canvas. So we have here a really super simple Svelte app, the script tag and a spin variable, and then this on frame just runs every frame and adds spin. And then in this rotation here, we put the spin variable. And the nice thing here is that Svelte Cubed handled all the state update for us. So it just does everything in the background. When you're writing normal Three.js apps, it's a lot more imperative than that. Like you have to write a bit more code to update the animation and things of that nature. So we have not just the mesh, but this perspective camera as well. You can see we have a position. Without the camera, we can't actually see any objects. All these geometry objects come preloaded with Three.js, so we can add different ones. Like we can put a sphere. We can put even some other weird shapes like tetrahedron, and there's a bunch more as well. So what we're going to do is we're going to build our own. We're going to create a few geometries of our own, various different ones here. A torus geometry, which is kind of like a ring object. A torus knot, which is this knot thing you see in the middle, and then the tetrahedron, which you saw there. And not a lot different to the demo that I just showed, but just adding a few different objects. And of course, we have our camera there too. So what we want to do is not just have a black background, we want to change the color of the background, and you do that from editing this alias here. So we add a background color to the canvas, and we can use CSS colors here. So we've added honeydew, and then that's changed the color of the background. For the camera we had before was pretty much just a static camera, but with orbit controls, what that lets us do is we can actually pan the camera. So we can do this with this orbit controls component. You see, we just had a simple component there, and we can actually, drag and move around and see the objects entirely. So the color of the objects you see there, they're kind of like rainbow colored, but that's really just for debugging. We're going to add some material to our mesh objects and give them colors of our own. And you do that by adding this material prop. So we have a material, it's a mesh standard material, and then we pass a color to it. So the top torus geometry is going to be purple, the torus knot is going to be yellow-green, and the tetrahedron is going to be red. But you'll see on the right there that they're all just black. And the reason for that is you can't see the material or the colors on the material until you add some light to the scene. And that's what we do here with these components. So we have two different types of light. Ambient light, this is the ambient only on the left. And you can see it sort of highlights them, but it doesn't look right. They're still dark. And that's where you need directional light. So that's almost as if you're shining like a spotlight at a certain part of the scene, and it will hit the objects in a certain way. And you can see the actual light hit the objects here. We're going to add a bit of animation to this now. So we're going to make the object spin and pretty similar to what we saw in the cube example. We just add the spin on frame, and then we add it to each of the mesh objects. But the difference here is rather than just do it on one axis, you can add on different axes. So this rotation here, it's just an array. It's like how close to the camera it is, and then the X and Y coordinates. And we can just bind the spin to these. And again, Svelte just handles all this in the background for us and makes it completely reactive. So the top one, it's just spinning, it's revolving horizontally. The torus knot, it's spinning on all three. So it's just kind of spinning all over the place. And then the same with the tetrahedron as well. So you can see how this kind of animation starts to work. And we don't really need to use any specific Three.js stuff. It's all just driven through state, which is pretty cool. So what we're going to add here is we're going to kind of add some DOM elements to control these things, not just have them spin by themselves, but add a couple of DOM elements to control animation and kind of shoot the shapes in different places, to edit the width, the height, and the depth of the shapes, and then to reset them. And we do this through using Svelte's tweened store. And what that does is it lets us declare a variable, a value, and tween it whenever we set the value on it. So for example, we set this progress to 0, and then when we call this animate function, it'll add 3 to that. And rather than just have the shape just jump from 0 to 3, Svelte will just animate that for us in the background. And you can use this in normal Svelte apps to animate things like sliders and divs and all that. But what's nice about this is that it works directly with Svelte Cubed. So we can do the same thing to 3D objects in WebGL. And here, you'll notice that there's a sort of grid here that we've added. And what we've done here is we've added backdrops and a shadow. And I'll show the demo for that in just a minute. But the effect we're trying to create is that you can see the shadows being cast directly from the objects onto the grid there. And it looks a bit more realistic. So this is the full demo here, just running inside StackBlitz. And I'll just kind of go through it and show the first bit that was in the slide. And we have our tweened and some event handlers to update the progress and have it animate. We have our mesh objects, and instead of binding to just static values, we bind them to the value of this progress store here. And the way you do that reactively in Svelte is with this $sign notation. So it's just when progress changes, update the object. We've also added these cast shadow props because you need to add those to the shapes to actually make them cast a shadow. We have our, the things we had before, the cameras and the lights to light up the shapes. And then this is the code here for the floor itself. So what we've done, we've added a mesh. The geometry is a plane geometry, which is essentially just a flat object. And then the material is this mesh standard material. So we want to make it blue. We then have this primitive, which is really just the grid part. So it just layers a grid over the top of the mesh. And then we have this kind of full little world here where the objects are just floating. We then have just standard HTML elements to control these things. So we've just added divs with buttons with an on-click handler to actually animate the shapes. And then the size controls, again, we can use Svelte's notation to just bind the value to the width. That updates the width variable, and it also updates the state of the shapes as well. So what's cool about this is we have all this kind of all this WebGL, Three.js stuff, and then just standard HTML. So it's a nice mixture between the two. And we click around these, we can pan the camera, can animate the shapes out, and they start to spin around, and we can just reset them, or we can increase the width, increase the size of them, their depth, animate them out, pan the camera, and reset. And again, Svelte just handles all of this for us completely through state transitions and makes the animations nice and smooth. So being able to create something like this in 130 lines of code is a kind of testament to what Svelte Cubed does for you in the background. So when I started working on this, ultimately where I would like to get to is something like this. So when I saw this WebGL example here, it kind of blew me away. It's like neon shapes, but you can see in the bottom here, it's almost like water on the ground and the reflection of the neon. And being able to create something like that would be really cool, but it just gives you a flavor of what's possible with WebGL and the sort of experiences you can create. In terms of the state, Svelte Cubed, it's currently in progress, and 1.0 should be shipped sometime over the next couple of months, I would imagine. They're just currently fleshing out the API and trying to match a lot of it to Three.js. So as you know, the docs and stuff are still early, but it's usable, as you can see there. You know, you can put together some basic examples and animate things. But what makes it different to something like Three React Fiber, for example, which is the kind of de facto React library for Three.js, is that React 3 Fiber, it doesn't really let you use the standard React APIs for like set state and stuff like that, because it doesn't perform. It asks you to mutate refs and do things a little bit differently for performance reasons. What I like about the Svelte Cubed approach is that it's just like writing a normal web application. You animate these objects the same way you would animate a div or any other HTML element. And it really kind of blurs the lines between 3D animations and complete 3D experiences and just standard, 2D web pages. And that's it. Thank you very much. I hope you learned something and you'll go off and have a play around with Three.js and WebGL. Cheers.
Awesome. Thank you very much, Martin. It was very cool and crazy to see the things you can do with just a couple of lines of code. So we have a good couple of questions here.
Sure.
The first one we got through is, how can someone join Martin's open source community? So
open source community? Oh, I'm assuming they're talking about Bodybase. Well, yeah, you can just jump on GitHub and we have issues and discussions there, and anyone can come on and contribute code, use the product, have a play around, and any feedback that people provide is always much appreciated.
Awesome. Another one here, what would you rather pick, Three.js or D3.js?
Well, they're for different things. Like D3 is a kind of, there are D3 developers, like in job titles, right? It's pretty much the all-encompassing chart library, and you can use it to build almost any kind of chart or visualization like that. Three.js is more specifically for WebGL and like 3D experiences. So if you were going to build like a game or like a 3D game, or some of those examples I showed you with like the neon lights and the kind of water effect, you wouldn't really be able to do that with D3. So they're for different things. If I was going to build a chart from scratch, I would use D3. And if I was going to do any kind of 3D modeling and stuff, I would use this.
Awesome. How does this perform on like less powerful devices? Is there like kind of a minimum requirement?
Yeah, it depends, but like most things, it depends on the complexity of the animation, right? So if you've got like a sphere that's just kind of revolving, you can run that on especially most modern mobile devices, right? They're gonna be able to do it. But I actually tried this on a few different ones, like on my phone, some of the games and stuff like that. And you're not going to get 60 FPS on like a fairly complex game on like not a very powerful device. So I think there's still work to do there, performance wise. And in general, Three.js is a big library. So in terms of bundle size and like page loading, you probably hit web pages in your time where they have a heavy kind of Web3, 3D animation experience. It takes a little while to load, but once it's up and running, the FPS isn't too bad. But that initial startup cost is definitely present.
Will it run on my Nokia 3310 or?
I think anything will run on that, to be honest.
We have a lot of questions. We have a lot of questions. We'll keep on time. We'll just get one last one because I think it could be interesting, and then you can always answer the rest in the chat.
Sure.
You mentioned Michael Svelte and your man Rich Harris. I've seen that recently he was hired as part of the Vercel team. I think that's the right name of it. Mm-hmm. How do you think that's going to change like the scope or the landscape of Vue or Svelte going forward?
Yeah, I think it's it's pretty massive, to be honest, to have him working on the project full time. You know, because up to this point, no one has. It's all just community driven. So I think like what you'll certainly see is a lot more support for the external tooling, things like Vite and Webpack and Rollup and all that ecosystem. That, you know, when you use Svelte, it's good for, you know, pretty much anything React is good for. But you know, that one library that you need, and it just hasn't got the support for Svelte, or there's, you know, some part of your build process that it doesn't quite fit nicely and you have to write a little hack to get around it. I think you see a lot of that stuff get ironed out and see it really come into the mainstream now. And, you know, there's already, it's seeing pretty good adoption from huge companies. And I think the future is very bright for it in general.
Awesome. Thank you very much. That was an amazing talk. Thanks, Martin.